We're moving into the second dialogue session, and I really enjoyed the presentations yesterday. It was quite a broad overview of various sampling strategies around the world, and information into methods details. So I think we have a lot of good questions to cover in a small amount of time. I want to, the audience has met Dr. Karina Jin and Dr. Erin Bivins yesterday. But we've got a new panelist that's joining us, and welcome, Jasmine, Dr. Jasmine, it's Grimsley, right?
That's correct.
Very good. And so Dr. Grimsley received her PhD in biomedical sciences and neurophysiology, MRC Institute of Hearing Research in Nottingham, England. But she's currently the head of the Science and Research Environmental Monitoring for Health Protection and the Department of Health and Social Care in England. And she's also worked with big data. She's been a senior data scientist with the Office of National Statistics in Wales, Newport, Wales. And she's also interacted with the academic world as an adjunct professor at Northeast Ohio Medical University. So she has a really broad experience. It's really amazing, Jasmine, that you've brought this kind of statistics and big data and together with the health side, and you've got that linked academic. So welcome. I think I can just turn the session over to you for a quick introduction before we, with your comments, before we go on to our dialogue. So I think you can share your screen. So
I'm going verbally only.
Oh, okay, very good.
That's right. Just briefly, so I'm the head of science and research for the wastewater program in England. And we've been running since we started sort of building out about last March. With sampling able to start in the end of June, beginning of July. We started out by sampling at 44 wastewater treatment plants across the country, sort of spanning England. And now we've stepped up to hundreds of wastewater treatment plants across England, as well as lots of in-network sampling across our major cities, as well as in London, looking at sampling at a neighbourhood level. So we're at about 2,500 samples a week at the moment, with that being daily sampling at the in-network sites because of the inherent noise that comes from in-network compared to 4 times a week at wastewater treatment plants. We're also sampling at another range of locations around schools, factories, universities, for example, and other locations of what we call our near source monitoring. So we have these use cases around near source, mid area, and then wide area monitoring. We're well integrated between the Environment Agency, who have really got the strong expertise and DEFRA on the laboratory methods, and running through to the public health and the use of these things for data, for insights, for policy, which has been, we've been really fortunate to get those good connections from early on. We're currently sequencing twice a week from wastewater treatment plants around the country to provide information on mutations and using multi-mutation analysis to look at variants, which is proving very insightful, as well as using it for, in some cases, lineage. We're using flow normalization based on chemical markers within wastewater, and building these into enable us to create better prevalence models and better insight into the number of people infected from the gene copies per litre we see in wastewater. And we've done a lot of work relating our data to asymptomatic models, to models of prevalence using symptomatic and asymptomatic individuals that are running throughout the country. We've tried a number of different normalization techniques and have ended up on the chemical normalization. I'd be happy to chat that through, as well as a number of different sort of extraction and filtration and different methods throughout the process, from sample collection through to gene copies per litre and variant information. So happy to answer any specific questions on this as we run through. Thank you for inviting me.
Yes, thank you. I mean, it's an amazing program. It's very large, and I'd like to have the panel kind of start off with some brief comments. You know, I kind of think of this in three parts. There's sort of the spatial temporal issue, like how do we set this up to really look at spatial and temporal changes, so to speak, or trends. And so where do we monitor? How frequently do we monitor? And is there an active monitoring strategy that we could use because of, you know, you're talking about hundreds of samples. And, you know, Karina, you were talking, you know, about trying to get at that positive in an area that's very low prevalence. And then I think about the methods itself in the lab, just throughput, efficiency, recoveries, all of that kind of thing. And then the final piece, really the interpretation of the signal, right? Which then becomes the critical issue in terms of decision making. And of course, this normalization and rainfall and infiltration into our systems, all of this kind of thing has been brought up. And are we kind of starting to reach a consensus? Everything's happening so rapidly in this field. I don't know if I can even catch up. No, you know. So let's start out with this whole issue of and I'm going to look at the chat and the questions and organize some of the questions while you're all talking. But let's start out with this issue of the spatial and temporal, you know, assessment. How do we get a handle on that? Karina, you know, some of it's trial and error. We're learning as we go. You know, can you address that a bit in the city-state island? Yes.
Okay, well, I guess we have the benefit from hindsight with working with NEA, because they had to deal with the workers' dormitories that came before we started analysis in the university. So I think it was maybe over a period of 3 or 4 months that they saw really high numbers in the worker dormitories. And so they actually had to grapple with the sampling issues then. And actually one of our students it was a researcher, went along to help out with them, which actually turned out to be very good for us because, you know, he learned from them. And then when he came back, then he shared his experience with us. So from the sampling issue, I know that NEA, and in fact, like if Li Cheng is here, yes, Li Cheng is here. I'd be really happy if Li Cheng also could share her experience with me while I'm talking about this. But I mean, I do recall that in terms of the sampling, I mean, they were able to detect positive for a block of about 500 people. And then that was based on their protocol where they used like 20 mils of sample. And I think one of the questions that came up yesterday, which we didn't have time to answer, was, do you think 20 mil sample is a good volume for detection? And actually, it does seem like a pretty small volume, and maybe it's not sufficient, but I think through NEA's experience, they actually did this validation and they actually were able to detect the positive based on 20 mil sample that was, I think, a composite over 12 hours. Li Ching, you can correct me if I'm wrong, and over 24 hours. So it's a night sample and a day sample. We actually have been doing a 6-hour period sampling over 24 hours. So that's 4 times a day. And we composite 2 of the samples so that in total we look at 3 samples, 3 time periods per day. So in a way, I think our resolution is slightly higher than what NEA did. So hopefully we should be able to capture if we did get 1 positive, because our blocks, I think the largest block is 500 people. Most of them are less than 500.
Yeah, I was interested in the, in the session yesterday where they talked about, and Li Cheng, maybe you can add to this, a negative in wastewater does not mean there's a negative in the population when you start to look at that, false positive, false negative rate. And so it's always, the truth in environmental virology, trying to prove that negative. Li Cheng, would you like to add a bit to this? That'd be fantastic.
Yes, I think it's the same for all tests, even diagnostics, right? A negative swab doesn't mean you haven't got COVID. It's just that we didn't we didn't pick it up. Yeah. So often you have to have an interpretation from different clinical symptoms and diagnostic tests to come to a conclusion of a diagnosis, or you do a second test. So I think it goes for all tests. So it's not very unusual. When it comes to our data, our tests, Karina, we do on an hourly basis. So our composite is 4 samples within the hour to collect 1 liter. And we bring this liter back, and then we use a portion of it then to test. So it's a composite of an hour. For that 500 in the community, that was actually in a housing area. It wasn't dormitory when we pick up 1 case among 500 people community. In that situation, we wanted higher sensitivity because it was an investigation rather than a surveillance. So we used the PEG method. I cannot remember the exact volume that we use. It's not very much either, but we do it on the hourly basis for several days. It's about maybe 10 to 12 hours per day. So 10 to 12 samples per day that we was sampling from that manhole, 1 specific manhole. Yeah,
so I really like the idea of that adaptive monitoring strategy where, we should think about, do we take a repeat sample from this, based on, our knowledge as we gain more knowledge using these samples. It's yeah. So, and remind us, how many locations in the city are you monitoring in terms of, the neighborhood level or the building level?
So building level is only for what we did was just for investigation. It's not on a routine basis that we did the monitoring because the community risk is very low. At that point of time, our risk was highest at the dormitory, the workers' dormitories. So we go for high population area where it is of high risk. People live together, people mingle, you share the kitchen, you share the bathroom. So those are our focus areas, But the community, we're extending to them slowly, but that is the priority is still the high population. For the community, we do it from the wastewater treatment plant. Right. So we have about 6 streams coming from the community, and so we monitor through that. We just have a few sentinel here and there. We are building up, but not much data has come up from there yet.
I mean, Singapore really has an advantage because the wastewater system, in these areas is so well characterized, particularly, because of the water cycle that, and the 4 taps program that you all have. It's quite interesting. Erin, how does that compare to your experiences, in terms of setting these strategies up? You think you've had some experience in different kinds of cities and different sizes and things like that.
Yeah, it's interesting. I was corresponding with a treatment plant operator yesterday and trying to come up with some estimates of the hydraulic residence time in the sewer network. And it really is just okay, it's this far away. Let's assume 2 feet per second or whatever. It's very, very rough understanding. And that's what's interesting about these systems is that our sewer systems are not really steady state systems. And I don't think we've ever been so concerned with how they function, which is, an interesting aspect of WBE. But, I think it's important to recognize that depending upon where you are, as you move up the sewer shed and there's less, you're aggregating less people, then the signal you can expect that a signal is going to become more variable. So if I'm monitoring a dorm of 200 students here at Notre Dame, and I'm looking for one person shedding this virus, when that one person goes to the restroom becomes critically important. Whereas we also are monitoring our main campus outfall, where we're picking up the wastewater from the entire campus. And so you can imagine, as we've aggregated more people down to this point, we see less variability in the signal. And so, you know, at our outfall, we're doing 100 mil every hour. I'd love to do less volume more frequently, but our peristaltic pump, we're pulling, it's like a 20-foot deep manhole. So, you know, our ability to pull 20 ml is basically non-existent. Whereas at the dorms, you know, our strategy when we're monitoring at the dorm level is we're just dropping passive samplers into manholes, basically little Moore swabs, and we're using a qualitative testing method. So we're running 3 replicates, and for each of those, I get 3 positives, you know, 2 positives, 1 positive, or none. So there's kind of a gradient, and we're reporting those results as strong positive, moderate positive, weak positive, or non-detect. And it's pretty fast, but it's very much qualitative. So depending upon what you're trying to achieve and where you're monitoring, things have to kind of be shaped accordingly, is what I would say.
Yeah, yeah. Yeah, I think the presence absence can help us quite a bit in certain circumstances. Jasmine, how are you? How did you decide to expand from your 44 sites initially to you said over 100 now? I think that,
well, we're actually in the many hundreds of sites if you include our core cities. We're covering a large percentage of the English population. We ran a number of pilots. So we started with pilots in network, looking at the different sampling strategies that we could do and the different timing of sampling via auto-samplers to subdivide the neighborhood level, and near source sampling at a number of different locations. I think one of the key things to understand when you're thinking about these sampling strategies at these different locations is you know, what's the policy intervention? So we haven't put in any auto-sampler into anywhere where we don't know what we would do if we found a positive, and completely designing that signal that you're collecting around what the intervention would be. So for example, in places where people may not be using the toilet as frequently, such as workplaces compared to staff accommodation, where we sample, you know, you've got this sort of morning peak and we're sampling at maybe 5-minute intervals or 15-minute intervals, depending on the size of the building throughout the day, to get that insight. In a workplace, one might need to sample differently depending on the shift patterns. So you can lock down to isolate to working patterns, or during lunch breaks, sampling them really closely for 5-minute intervals and sometimes less, to really gain those rare events and those rare signals. And with the bathroom habits bearing in mind, when you're looking to these near source and you're stopping from trying to get insights on a population level like we are at treatment works, just to understand is, you know, what is the shifting prevalence over time? How do we prioritize resource and those kind of questions? And you start really being able to, about detection, really need to start thinking about how rare that event is. So now, for example, if you're trying to isolate somebody with a particular variant, and thinking of how often people are likely to be able to using the bathroom, that may be looking at 1 or 2 cases, and, you know, looking for a needle in a haystack, essentially, one needs to increase the sampling frequency and also send things for sequencing for multiple days in a row. So if by doing pockets of data, or even aggregating data from pockets, depending on your prioritization of resource, you can better get insight into whether something is a single event or something systemic in an area by seeing those patterns of change over time. And so
yeah, I think that's it's so key to match up the idea of results, right? The idea of what we're going to do with the results with your strategy. And then, of course, it sounds like everybody's looking at matching that up with population, you know, some knowledge of behavior. So, you know, whether it's a smaller population at the building level or a larger population at the city level makes this difference, as Erin has mentioned. Li Ching, did you have another comment to add to this? I see your hands raised.
Yeah, I want to ask a question. I think Erin mentioned about, did you draw water from 20 meters or 20 feet?
Oh.
A depth.
20 feet. Our
20
outfall
feet.
manhole is quite deep, and so we because we're using a peristaltic pump to get the pump head, the lift that we need.
Yeah, yeah.
You know, about 100 mil is the lowest we can go. Otherwise, we spill sewage everywhere. So we're doing 100
because that's our challenge as well. So 20 feet is, sorry, 20 feet is how many meters?
Maybe like 6 meters.
Oh, 6. Okay, so it's about the same. I was just, no, I mistook it as 20 meters. I wonder what kind of pump you have. Okay, thank you.
Haven't pumped that deep.
So we had the same problem.
Let's go a little deeper in the Midwest here, where we get these cold temperatures, right? Our sewers, but they're pretty warm. Sewers are warmer, I think, than others in terms of freezing. We got a question, and I did want to just make a comment on one of the questions that came up about, and it relates to this idea of interpreting the signal. And I'd like all of you to try to address this as we go, and let's talk about this normalization and the things that go into interpretation of the signal once we get the results. But it was about persistence. So we had a question from one of the audience members about the persistence of the signal and persistence of the virus in general and whether it could replicate. So just for the audience's information, for those of you that aren't familiar with viruses, they don't replicate in the environment. They only replicate in their host. So once they're excreted, what we have is sort of like a chemical marker. We get, especially with PCR, we get sort of a degradation over time of the signal, the PCR signal in most cases. We're not really even looking at whether the virus is alive or not, but it's not able to replicate. So the stability of that signal, to your question, I'm not sure who asked that question, but the stability of that signal is really important. And we heard some of the presentations about trying to get at that, how the signal degrades in the sewer, if it ends up in the biosolids, post-treatment or during treatment, or once it's discharged maybe in a river. What do we know about the degradation of that signal? So that's really important. I think normalizing this signal, all of you had talked about a bit about that, but we've got recovery. People have used recovery or not used recovery, normalized by flow, not by flow, by some other marker in the system that indicates hopefully loading, right? Fecal loading to the system. And then whether you're trying to use persistence in some of these travel times, understanding the travel times. Erin, maybe start with you, and then we'll move to the other, to our other panelists in this regard. That's a lot to chomp on in terms of, but basically, how do we interpret this signal with these variables?
Yeah, I think variable is the key here. You know, we're trying to get our hands around the variance in this system, and we're using different techniques. Normalization is one technique to try to basically tune this signal a bit. And you know, what I've seen in our data here is that we've been normalizing by pepper mild model virus. And what I've found, it reduces the variance quite a bit, obviously, but there's still not necessarily distinctive signal between, you know, increasing number of cases, but it does help a lot. One thing I would say, a couple reasons to be a bit cautious. You know, depending upon the idea is that if we're going to look at trends over time, there can be variance so long as it's consistent. And so, you know, one of the things to look at is what we've seen for SARS-CoV-2 is our recovery, at least as we've estimated using our process control, varies substantially. See coefficients of variation of anywhere from 150 to 200%. And so that's why we've been recovery adjusting, because we feel like that's one variable that could potentially change the direction in a temporal trend. With pepper mild model virus, the recovery is much more consistent. And so when we normalize, we need to think about the variance of one piece compared to the other. But you know, I've yet to do a rigorous analysis, but those are some of the things we're thinking about and that I think are definitely worth having a look at. with our numbers. For us, I've only looked at about a few months worth of flow data, and I think it was during a dry period. And so when I went through and made calculations that were flow weighted, I didn't see a large difference. But I think that's probably because we weren't getting a lot of dilution from rainwater for that period. So
Right.
to summarize, I look at recovery, flow, and normalization. I look at all three to see what the temporal trends look like for each of those.
Yeah, I think it's an sort of an interesting point, because some of the variation is real. You may have more cases, or I don't know if some of my hypothesis is that when the early in the infection is when you get the highest excretion rates. And so that variability we want to understand in the wastewater signal, but we don't want our methodology and rainfall and other flows to influence that signal. So how do we kind of get at that? Jasmine, have you been able to, you said you were normalizing by chemical markers.
Yeah, we've got a
So
number.
could you talk a bit more about that?
Yeah, we have a number of models that we've tried for normalization. So we've tried things like crasphage, which worked well for some sites and not others. So we moved on to normalize for flow based on those, based on sort of ammonial nitrates and other inorganic markers, which has worked really well. And when we look at it at the works, it relates very strongly to flow metrics. But obviously there's a cap on flow. There were in a storm event, the flow maxes out at a treatment works where perhaps there'd be the surge release. And it's good to see that the continued markers of dilution carry on within our model beyond that. And so we find that, to be honest, flow has a very little change other than extreme events out in the network and in some of our sewer areas where it is combined flow. In most of our sites, this normalization for flow only has a really sort of smidge of a difference on our signal.
Yeah, I'm always wondering, because we have very leaky systems in the US in some cases. So we have really, we can have some really high infiltration in some of our sewer systems. But I'm wondering, why not normalize by population,
So we're
understanding how much water each person kind of uses in a way. Can we use that as well? And I think there was a, go ahead, sorry.
So I know, so we have been using we have looked at sort of a normalization by the average amount of water that you'd expect used by individuals, and that's especially useful near to source when you're looking at, say, like a university campus. But I think when you get wider, what we found that at a treatment works, it's when we model the levels of uncertainty in the signal that are coming from different sources, a good marker for almost this travel time in the network and this degradation of the signal can just be the physical size of the catchment and combined with the population of that catchment. So essentially a distance population density going into a regression model.
What chemical marker were you using? You said you had decided.
Ammonial nitrate.
Pardon?
Ammonial nitrate.
Oh, okay, very good. I was wondering, there was a question about the what we know about the difference between using the pepper-mild multivirus and the crasphage as two markers to normalize. Do you have any sense? You said you tried both, and you're evaluating whether they work based on the relationship with the cases?
Yes, we relate back to case data as well as to, in the UK, we have some excellent surveys which are done on stratified samples across the population, especially one run by the Office of National Statistics, which looks at asymptomatic case rates. And so we can use that to sort of build in epi models for case estimates. But
well, I've always been envious of the UK public health system in many ways, just because of the ability, across the country to actually, get at this surveillance. You have a very good surveillance, program for the people, right? And so now we, like you said, you can relate that back to wastewater.
Yes, we've related that back to wastewater to look at the, and when we tried, sorry, just dropped my book, when we tried the different normalization methods, what we can do is we can look at the impact of them and whether they're shifting us closer to or further away from these models that we have of instance. We've been very lucky to get the data for those provided so we can create sort of regional aggregates that just carry for our treatment areas where we're capturing from. And so look, and from that we can understand our lead, our lag, really what part of that fecal shedding pattern that we're related to, and really tease apart exactly what in the signal we're measuring at sites of different sizes.
Yeah. So Karina, you've got to handle so this it's one of the problems we have in environmental sampling, the negative. What do we do with the negative, right? The negative results, because they're still meaningful, right? And they can be meaningful. What are you guys doing in terms of, you know, advancing your normalization or handling, you know, besides, of course, you talked about detection limits, but besides that, there's other things.
Well,
right?
I mean, we're also using PMMOV as our process control. And actually, yeah, we're trying to see, well, we're trying to also look at crash phase as well and try to relate that to the population of the students. But at this stage, you know, we're still just using, we're just trying to look at positive and negative detects. We're not quantifying, but I mean, because we haven't really, yeah. But yeah, our plan is to try and get a feel of the numbers of the, at least the concentrations of the PMMOV. We will do that at the next stage. And actually, I think we've already seen that you know, the numbers or the signals for the PMMOV correlates very well with the students' usage of the toilets. So that's
during surveys.
Yes,
you got to put the smart toilet, you see, Karina, the smart toilet in as a, you know, in Singapore, why not? So how are you getting the survey of when they're using the toilet?
I think Hao Yong did that earlier on at the beginning of our study when they were trying to figure out, you know, when the students were using the toilets, and so we also monitored the PMMOV. But on top of that, though, we're also I mean, we are collecting samples now for chemical analysis so that we can look at the chemical markers. So for that, we will, you know, do like what Shane mentioned earlier, things like caffeine, artificial sweeteners, PPCPs, a whole range of chemicals, which we will look at together with the microbial markers. The viral
I think it's going to be interesting because a lot of those markers are more related to urine and how does urine and fecal matter. I'm sure they must correlate a bit, but of course there's a little bit, we don't know. Seems like there might be more urine signal than fecal signal.
True.
And yeah, so but I was surprised to hear Shane say earlier that they saw a change in flow with these rainfall events, because I thought Singapore's system was pretty tight. I didn't think it was that leaky. I thought there was a lot of effort to change that. Are you, you know, how are you dealing with various flows, or is that happening at the wastewater plant, not so much at the building level?
I don't really know about from that point. I think maybe Hao Yong might have a better sense whether rainfall is, because he's handling the sampling side, the auto samplers. Hao Yong, are you there? He might have stepped out.
Multitasking. He's multitasking.
I'm just back. Sorry, what's the question?
Yeah, no, because yeah, we're just wondering whether rainfall has an effect on the sampling, the auto samplers.
Okay.
Yeah, because Go ahead.
So the question, okay, for our auto, sure. Can you hear me?
Yes, we can hear you. I was just saying Zoom, you know, it's hard to moderate Zoom because you're always like, you know, interrupting people when they're about to start speaking. Yeah. Go ahead.
Yeah, so for ours, because our sampling point is pretty near to the the hostel blocks itself. So we are not impacted by the rainfall because the sewer pipe connect directly to the toilet bowl itself. So we don't see an impact due to rainfall. And this auto sampler itself is weatherproof, so we don't see any issues for our case.
But I was just thinking that maybe things like using washing machines
oh yes,
might have an
so,
effect.
okay, that has an effect. I think some of the toilet system, they have certainly they have washing machine in the hostel. So that is the part that we honestly we do not. That will depend on your this PMMOV detection if you see a difference, because we do not know when they're going to do their laundry washing. It could be spread throughout different part of the days. Yeah.
So, Hao Young, I wanted to ask too, there was an answer in there about sampling, you know, at deeper levels. And so we got an answer there in the chat, and Shane has a comment too. Shane, why don't you unmute and we'll go to you next. But I did want to ask you, Hao Young, are we going to have like a summary of some of these Q&A that has been captured in the chat or the Q&A session that's going to go back out to the participants?
Good question. And in fact, we will put up the recordings for these two sessions.
Oh, yeah.
For these 2 days. So we will put it up. But we haven't decided that we're going to compile an answer to all the questions yet. But definitely the video recording is going to be available. In fact, yesterday's sessions are already up on the website, NERI website.
Right, I saw that. That's fantastic. Yeah. Okay, very good. Hey, Shane, you answered the issue of the rainfall. Do you want to add to that a bit?
Yeah, I mean, just a quick comment to your question. So we observed it, and we thought we were correlating the rain and what we saw in terms of the markers, the fluorescence, the entire package. But we asked PUB if it could be so, and they said yes. So I trust PUB. I mean, it looked like that to us, but they confirmed that it does happen.
This was at the wastewater plant, Shane, at the wastewater plant. You saw the relationship.
Yeah, predominantly at the water reclamation plants. Yep.
Yeah. So somewhere along the line, even though Singapore's pretty tight, it still rains, still influences our wastewater systems. Yeah, Hao Young.
Maybe I add on to that. Actually, this is the same question that many years I was wondering, because Singapore, we have a separate system, sewer and the rainwater drainage systems. So I spoke to PUB people, why do we see a dilution of wastewater? There's an infiltration during rainy season or right after rainfall. In fact, it's to do with the apartments, the government apartments, because especially the old design, they always have a waste rubbish collection chute. And right at the front, there's an opening where in case there's any spillage or rubbish, it will go to the sewage. So that is
all right. So yeah, I see.
Place where all the rainwater will go in. So that is a very obvious. Okay.
All right, very, very interesting. Well, we know in the U.S. we're much leakier than Singapore, and so even in Singapore, so it's definitely something I think we have to think about. And when we're looking at these signals, I don't see any more questions emerging or a hand raised, but I did want to talk about the sequencing methodology, because I think these new variants and the role that wastewater could have to look at what's happening in the community. I did just see a paper, I think it was from the UK, can't remember the authors now, Jasmine, about seeing the UK variant emerge over time in the wastewater signal, you know, and they could see it growing as in relationship to, you know, the variant they were looking at before, I guess whatever we're calling the the original variant. And you mentioned that you're sequencing on, how's that, how are you merging that whole technology and techniques with your results for the monitoring program in general?
So it's pretty early days for that at the moment. So we're currently doing a number of experimental methods to understand how to build it into our epi models. So to understand how how best to use this and how best to work with stakeholders around it, and building out this response framework for what you do when you get a positive, and how certain we can be of our detection thresholds. So to do that, one needs to go back in time and compare the rise of a known variant, for example, the variant that's emerged in the UK, and compare that against the clinical detection thresholds for those mutations. But we're going by, although we are able to look at lineage, we're predominantly looking at multi-mutation analysis. So looking at a suite of mutations, and because of the during a high prevalence time, then looking at a variant is a very different task. So I think one of my keen interests here, as we think about laboratory methods, I think is the where we need to be moving in future, is the ability to extract from large volumes without increasing our inhibition, to be able to move beyond these indications of presence, absence, or quantitative measures. But if we want to look at that diversity in the signal, how we step forward and do things like these sort of dialysis methods to really sort of shrink down and pre-process to extract from a large volume and really start.
Yeah, and it's hard in untreated wastewater, because of the, suspended solids and other materials. And I think this is going to be very important. Did we have? I was wondering, and I haven't seen it yet, but of course the literature's flying fast and furious around me. So whether the new variants with their changes are as efficient in replicating in the gut as the Wuhan strain. So I'm always worried that, we're looking for the variants in wastewater, yet some of these variants may have less efficiency in the gut to those cells. I'm not sure. Do we have any evidence on that yet, or knowledge?
Not that I'm aware of.
Yeah. So Aaron and Karina, what are you guys doing in terms, are you doing some sequencing, trying to do some sequencing as well? And looking at the development of these new variants that are popping up? Karina?
Oh, we haven't started yet, but we because we've only just got our whole lab protocol running and getting the whole setup. But now, so we've just started like our chemical analysis, and we're also starting to save our samples to look at metagenomics. So we'll just take us one step at a time.
Oh, good. We'll
are...
let you guys read all that literature that's popping up and help us. Oh boy, Aaron, are you guys doing sequencing as well?
We've not touched it yet. And to Jasmine's point, the way that we're concentrating our samples with these electronegative membranes, we bead them to extract them, and so we're shearing a lot of RNA when we do that. And so we've got concerns around, okay, let's say we detect a mutation. A variant is not an individual mutation, it's a collection of mutations. So how do we control? We can say that a particular mutation is changing in its signal strength, but how do we put that together and conclude that they're on the same genome? And so that's just something that we're like working through. I'm sure there's other people far ahead of us, but because of the way we bead our samples, we're just not sure about the signal that we're going to get out of them.
I think one of the important things to do there is to look to see if you have the multiple mutations on the same strand as it's amplified, right? So the co-location of say the N501Y and the E484K, and this, if you can start seeing sort of co-location, that really helps. But I think we're using sort of the precipitation methods for extraction. We're currently using the ammonial sulfate, but we are interested in looking at the Innova prep, which has a lot of consumables and it's quite expensive. So we're keen to understand the benefits if anyone's used that method.
I think
Yeah, I
another
think
thing,
coming up with, oh, Aaron, go ahead. Sorry.
with the dead end ultrafiltration methods or recirculating ultrafiltration, I saw some people that were targeting like the primary effluent for those so that they could get a larger volume through. And I've not there's only 24 hours in a day, so I've not tinkered with that yet. I wonder if that might be a reasonable approach.
Yeah, we've seen the ultrafiltration work well. We've been doing effluents, and I think very much like trying to look at removal of the signal by treatment processes, but untreated it can be more difficult. But once you get to secondary, you can get larger volumes. Just have to take into account maybe you have different recovery efficiencies with the two concentration methods. But yeah, it's quite challenging. We're learning something new every day. So we only have maybe about 10 more minutes, and I wanted to give each of you, and then we'll see if there's any more questions from the audience popping up. But if you have a couple of recommendations for studies in the future, recommendations about the things you found out in terms of methods or approaches, what might those be? So maybe one recommendation on the method side, what you've learned, and then one recommendation in terms of how you might, recommend to this community out here. This is a very large, growing community that's quite highly multidisciplinary, right? We've got the environmental chemists, and we've got wastewater engineers. So from your experience, do you have some recommendations you can give to this audience? I don't know who I can put on the spot first while the others are thinking, oh, what recommendations do I have? Does anybody want to volunteer to go first while you're thinking about this? And maybe we go through a round. What kind of recommendations might you have on the methodology side of it? So Karina, do you want to start there, and then we'll do 2 rounds, and so people have time to think.
Well, I guess for us, I mean, we had big issues when we first started with contamination, and so I guess that's something to bear in mind when you're starting up on this thing, because because we were monitoring daily, and so if you actually have one, you start this contamination issue, it just gets worse and worse. So I think that was a big learning lesson for the team, that you had to be really very strict with cleaning and even just things that we didn't think about. We learned the hard way, and so yeah. So to us, I think the big learning lesson was really follow the procedures, do the cleaning, do everything in the BSC as much as possible, decontaminate anything that comes out. If you get out of the BSL2+, also take out all your PPE change, and you probably have to work with split teams and teams preparing reagents outside your main lab and so on and so forth. So that, I think, for us was the main takeaway when we first started.
Yeah, Jasmine, I'm going to turn this over to you secondly, but in addition to your recommendation, there was a question about whether you've tried TSS or BOD for normalization at all. So maybe you could answer that question and then get to your recommendation on the methodology.
We haven't used TSS. I think we did look at BOD for a while. I can't remember the outcome of that, to be honest. But for normalization, we also looked at things like suspended solids and a number of other metrics. I think we could probably do a whole meeting just on normalization, wouldn't we? And then with the recommendation, I think one of the things we found, especially as we scaled, when we were in a small pilot program, we had really good communication right through to our teams collecting samples, them really understanding how to collect those samples and how to do that well and how to store them. And I think as we've built, we found it's really been incredibly important to build a one team field right through from the people collecting the samples right up to those analyzing and processing the data, so that you get communication all through that pipeline to lead to quality data. Because we had, you know, issues, and it was communication issues and understanding of why it matters for the people hired to collect samples from in-network, of how to store those samples and how to collect them well, and really leads to a lot more of a stable, continuous signal. And to really sort of, I think we can focus on so much that we can control in the labs and all those things, but I think if you're getting a good sample out of the network is so important, and getting buy-in for people, and on an emotional level for what they're doing and how it's being used in the end is really important.
Yeah, I think it's really important, that communication piece, and we're seeing that in our Michigan network, and we're meeting once a week, the whole team, and that's been extremely valuable, you know. Aaron, we've given you lots of time to think about your recommendation.
Better have a great answer. I think one thing that is striking to me is, you know, there's two things. One, viruses, you know, in general, are characterized by a wide range of morphologies and structures, and I think we would benefit if we think in that way in terms of their behavior in wastewater. And you know, we know that SARS-CoV-2 seems to partition to the solids favorably, but it also seems, based on some of the literature I've read, that that's probably driven by solution chemistry and by the physical chemistry of the solids themselves. And so, you know, in some ways, when we are theorizing about these things, it helps us to think of them as homogeneously distributed in the wastewater, when maybe not. And so when we're preparing our subsamples for composites, things like that, I think some of our usual assumptions are maybe not in play because of how this virus partitions. And so, and I think that makes a difference in what we see in terms of the persistence of the RNA signal, in terms of recovery. And so I think that, you know, we're still figuring all that out, but I think it's worth thinking about in terms of your methods. I've found for us that being more concerned and cognizant about the solids fraction seems to help us in terms of our recoveries and our sensitivity and all of that.
Right.
Conversely, I would say, in terms of the like big picture, is starting with the end in mind and saying, okay, what decision is it that we want to make? At the end of the day, what do we want to be able to do based on the information we collect? And then you have to build your surveillance system with that end in mind. And because a lot of the decisions you make along the way are trade-offs. Everything is a trade-off based on what you want to achieve at the end. Do you want more sensitivity? Do you want rapid results? Do you want an affordable method? And so depending upon, you know, what you're trying to accomplish, you can tune your system. So they're not all going to be the same. And it's going to vary depending upon the context and the objective. Yeah,
that's very true. Karina, do you have one more big recommendation to give to the group? And I'll make some, I'll have let Jasmine have the last word, and we'll close and go from there.
Not really. I can pass it to Jasmine.
All right, Jasmine.
I guess mine is more in the what next recommendation. Is we really need to do something about the ability to understand signals and areas where we can't get auto-samplers in. And so I think I raised this earlier around more swabs or things that we can leave in network in small areas in these parts of cities where, you know, manholes are in the middle of the road or you know, on pavements, where we can get insights aggregated over time of potential prevalence or instance of variance in those areas. And I think that that's the big gap that we have right now, that I'm certainly focusing on for trying to understand what to do.
Yeah, it's really interesting that, you know, the more swabs and this type of a technique, which was used early on, like in the 50s, I think, for polio virus, you know, is come back to say this was a valuable approach and inexpensive and this type of thing. So Yeah, so I always say, don't worry about reinventing the wheel because, you know, it took us a long time to put wheels on our luggage from prehistoric times when they put wheels, you know, used wheels. So I'm like, yes, let's reinvent the wheel. It's fine. Let's go for it. Okay, this has been fantastic. Thank you, panel, for, you know, your comments. It's so valuable to have this conversation. You know, I think we get at some of these issues a little bit, you know, better than just presentations in many cases. And there's a question about persistence and viability, and maybe even using BSL-3 lab data to understand infectivity of the pathogen versus these surrogates, because I know Shane mentioned using all these surrogates. So I'm going to pass that question on to the next panel. That's Dr. Gertrude Medema, I think, maybe chairing that. So Gertrude, I'm giving you your first question for your next panel. It's a good one too. It's a difficult one. So thank you very much. How Young?
Yeah.
We're taking another break, I think,
Yes,
and then we're moving to the next panel. Is that correct?
Correct. We will have 15 minutes break.
It's nice to have these little breaks. Go get, I'll get my coffee, and those of you in your evening can go get your beverage of choice, I think. So, okay, How Young, I'm going to turn it back over to you. Thank you, panel.
Thanks. Thank you.